Hey, I'm GamerPatty, and today I have an amplifier to repair. It's an NAD 2200 power envelope. There's also a 2200 non-power envelope model around, and it's a little bit different, but they're basically the same device. And yeah, I just received this in the mail. And some screws on the sides are missing already. And the previous owner said it just went off while he was listening to music. So let's, before I plug it in, I want to get sure that it's set to 220 volts. A common problem with these is that they're made in the 90s or 80s and the line voltage were at 220 volts. But today we have 240 volts, so it's a good idea to set the power selector to 240 so the amplifier doesn't get overloaded with too much voltage. Those bus caps are already running at the limit. There we go. It looks very dusty. So what we have here is the 2200. It's very dusty. I gotta clean it before I seriously work on it. And as far as I can see, someone's been in here before. If you wonder, those caps they are fine. They look a bit bulged, but it's just a plastic cap. The metal part below is totally fine. It's just a plastic. So first problem I see is the voltage selector is a little weird. Maybe it came loose. That's a common issue, that they pop off and it just stops working. Another issue are the relays, but from what I can see, they have been taken care of, not really professionally. Just some flying leads, some relays just plugged in. I may replace these later. That would be a good idea. And yeah, someone's been definitely in here. So let's check the fuses. First off, the left channel, positive and negative. These are fine. The mains, also fine. Or this was the right channel, I think. The mains fuse, I don't know where they are. They're all fine. So let's just check the voltage selector. It is set to 220 volts, as I said. It's not ideal. So let's change it to 40. It's hard to see. It's the most left option. And someone already glued it in, which is a good idea, but only after selecting the correct voltage. So I may even have to remove it completely and just jump the wires. Let me see if I can adjust it and break the glue a little loose. Nope. It's totally glued in. Great. Anyway, I got an isolation variac transformer, which I can set to 220 volts. So let's see what it does and what it does. Let's see, I'll plug it in. Go to 220 volts and let's check the LED status. We are in protect. and we are stuck in protect. This can have several reasons why. The most obvious reason is one channel has died. And when one channel died, usually the transistors go short circuit and you have like 80 or 50 volts on the output. That's not good for your speakers, so the protection circuit kicks in and it stops that from getting out. Another common issue with a protection LED that's always lit for no reason, even if your amplifier boards are working fine, is that those capacitors on the back are dried out. There is a circuit that basically, imagine a bucket. You got a bucket, and when you have an AC, like taking water in and out all the time, the bucket never fills up. It always stays at 50% or whatever. But if you have a DC offset, like 50 volts on one channel, the bucket fills up. And then the relays go into protection mode. And in this case, when a capacitor is like a bucket, and when the capacitor dries up, the bucket gets smaller. You get less capacitance, and it may be that this capacitor is dried up and now has so little capacitance that it never goes out of protection, literally. I can check that by just measuring the speaker outputs. I'm sure these leads are the white one and the red one are the speaker outputs. I just hook one lead of my multimeter up to a negative point. A negative is usually on the back, the negative terminals. That's why I said there is also a 2200 model in the beginning, because the 2200 non-PE model has positive, negative, positive, negative, whereas one positive is actually negative. They're running one amplifier backwards to make it easier to switch between a bridged mono and stereo. This amplifier, on the other hand, has like two identical amplifiers that run at the same phase, but you have a board on the back that where you can invert one phase to bridge the amplifier. So one amplifier drives the positive wave and one drives the negative, and vice versa. So let's hook in the negative lead to a negative terminal so I get a good connection. And let's hook up the multimeter probe to first off the right channel and see, turn it on. And what do I see? Let me bring it in shot. As you can see, it's 36 volts. That's not normal. It's slowly going down. That's also not normal. Usually it's stuck to a rail, and the rail is usually much higher than this. Let me see where the rail is. Got a bad connection over there. Also got a bad connection. What's going on? Let me check this one. 99 volt rail, which is not ideal because those capacitors are only rated to 120 and 80, and you don't want to run them at their almost at their maximum power point or maximum voltage. So it's 64 volts, so the output is about 33 volts. It could be a problem with the offset circuit. Let me check the other channel. It could be a problem with the input. It could be a problem with the decoupling capacitors that are not decoupling anymore. The left channel seems alright. The right one definitely not. Yeah, let me just quickly disconnect the right channel and see what it's doing. Hopefully the protection board isn't being powered from the right channel. I don't think so. Yeah, let's see. To depower the right channel, just remove this ribbon cable. It's very easy, just unhook this clip and then easily pull it out. Don't bend any pins and don't touch anything, because you still have those big capacitors that may be charged. So let me again check the amplifier. And protection went off. I didn't hear any clicks. That's unusual. But let me try again. Oh, protection went off. That means the protection circuit may even work still. So I gotta fix the right channel. And already I can see some components that don't look this healthy anymore. And let me zoom in. As you can see, those two resistors are not, they don't have some fancy color coding, it's just they're burned for some reason. I don't have the schematic right now. I don't know what they are for. I don't know what value they are. But I can look on the other channel to see, to get a rough idea what they could be. So before taking it apart further, I just check the power lead so that I don't have any residual voltage on it. 9 volts, 5.8, minus 1.6, minus 1.4, 1.4, ground. So yeah, it's safe to take it apart now. I also turned off the isolation transformer. And the next step will be to take off the bottom cover and check the transistors if any of them is shorted, which I don't think. It's probably just a few resistors that may have overheated. I see another few, but yeah, they'll look fine. They may even be still good. And I see another resistor that has some new color coding and new values. Take the amplifier. It's quite big and bulky, and no matter how far I zoom out with my cam, I never will get it fully in shot. So let's just flip it on that side. So it's easier for me to work on. Okay, let's go. I gotta watch the camera because I'm bumping it with my head if I don't pay attention. Let's take out those screws. The reason it failed could be because of the 220 volt selection. The amplifier stages get more voltage, they burn more current, they get hotter, basically. The other reason is one of more common, like the potentiometers to set the idle current and the DC offset, more like the idle current, they are quite bad quality. So they might drift over the years, and I think they initially set them to 5 millivolts on the emitter resistors, which is I think it was 20 milliamps for the output transistors, and when it drifts it's quite touchy actually, and when it drifts the output transistors burn more energy because their bias current goes up, and they get hotter, it degrades faster, and so on, and at some point something will just burn up. If the bias current is too high, then something will just go up in flames. That's what I like about NAD. You always have a service plate on the bottom, unlike Rotel, where you have to take out the whole board and everything. On NAD you just take out a few screws and you got full access to whatever you want to do with it. So the problem was on the upper channel. So let me check the transistors. I already disconnected the upper channel from power. I go to diode mode, and let me just reposition it so I can see it as well. Let's just check the transistors. 0.5, that's good. 0.49, that's also good. Everything at 0.5 plus minus 1 or 0.1, 0.2 is good. That's a different one, that's probably an NPN. I have to swap the leads over, do I? Let me check. That's good. That's good. And also good. Green one. Yeah, a beeping transistor is never good. Someone's been in here as well. Let me check these. Well, it could be shorted through this one, so I have to desolder both and check them individually. And let me check this one. That's good. That's about a bit low. That's a little bit low. 0.16. That's very low. And what is this? Some sort of diode? Never seen it before. But it looks fine. Yeah, it looks fine. Let me check the biasing transistor. Also looks fine. So let's just desolder these two and see which one of them may be broken. Also a common issue on these is the thermal paste dries up and they just get too hot and die, literally. Another problem with NAD amps, especially the later ones with the round power knob, is that those transistors with the metal back, they have a plastic washer to insulate the screw from the transistor so it doesn't short to the heatsink. These also have insulating pads on the back. And those washers, because the potentiometers drift and they get hotter and everything, they melt. And then the screw touches the transistor and shorts it out. So let's turn on the soldering iron and just take out the transistors. They're just soldered on the PCB, not through. It's quite easy to take them out. Just add a little bit of fresh solder, leaded if you can. Always use leaded if you can. That's good. Just suck it up. Just like so. I've just bent the pin a little. Always clogging, just like so. That's good. Now just bend back the pins a little bit so they don't touch the PCB. There we go. And measure again. So emitter to collector, and it's short. This one is dead. This one is dead as well, but the base junction isn't dead. It's on you. That's okay. Yeah, okay. Yeah, it's dead. Yeah. All right. So these transistors are 2SA1302 They are still readily available, just not as a Toshiba part, maybe as some ISC, semi, or whatever. And the newer ones are better. No matter what people say about sound and blah, you can't hear the difference. Newer ones are better. So I just replace those two. Ideally I would replace all of them, but that's way too expensive. Maybe I replace the ones on the other side as well. What I certainly will do is replace the thermal paste and the burnt resistors, obviously. And yeah, it's also a good idea to check for cracked solder joints. These are single-sided PCBs from the 80s. That's like paper, pressed paper shit. And when it gets hot, like on these parts, it's a little bit dark. Those solder joints can become very brittle. And it's always a good idea to visually inspect those. And if you're unsure, just resolder the spots that have a big part on the other side, like a transistor, a heatsink, a connector especially. All parts that are under stress or have a lot of mass behind that can crack it. If it's just a resistor, don't bother. They may crack, but it's very unusual. Let's take out the second one. So now that I've desoldered this part, which I didn't do properly, I think I just bent up the pins a little bit away from the PCB so it also doesn't touch. And I obviously cut myself. Let me check. Just like so, and it's loose. It's also quite loose actually. That means the screw has come loose and maybe it lost a little bit of contact and got too hot, probably. Let me check in diode mode. Yeah, it's short. What also can fail, well, what will fail actually, are the emitter resistors. The emitter resistors are that three-legged big white blocks on the other side. And let me see, these ones are the emitter resistors, and they usually burn up as well. Obviously you can't get them anymore, it's from the 80s. But you can replace them with two normal 5-watt resistors and these cemented power resistors that work just fine. Just plug them side by side. So let me check the resistor. It's this one. It's open. Open. Let me check the other side. This resistor is good. So yeah, the resistor is also burned up, as expected. When they burn up, like this one, it's short between emitter and collector, and it's not short to base, which is good, because that means everything that's connected to base isn't blown up. But let's see this one. It's short to collector and base. That's a problem, because this way the driver transistors that drive the base may also be dead. Let me check the other side where it's going. and I can see where, but I see a few transistors on the side. Let me quickly check this one, and it looks fine. Let me check the forward voltage. Yeah, it looks fine. Let me check the other one. It's also, yeah, no shorts there. And let me see if both base pins are connected together. They are. I'm just looking for a short circuit. I don't know if they actually work. They seem fine, no short circuits. That's probably just these transistors and the emitter resistor and the other resistors that have burned up. When you replace those resistors, the ones you've seen that have burn marks on them, be sure to pick the right ones. You can just plug in any resistor, literally, if it meets the power requirement. Those cemented metal oxide resistors are, I think, half a watt or something, and they serve a special purpose actually. You can plug in a carbon or metal foil or whatever they're called, these normal resistors, if you have the right power requirement, but when it burns up, it creates a flame. These resistors are made of ceramic, and when they burn up, they just get hot. They don't catch fire. And as you have seen, there is a lot of dust inside, and it may even cause a fire. So these are the transistors, the Toshiba, and as you can see, the thermal paste is it's almost like a ceramic. It's not thermally conductive anymore, really. And I also will replace these glimmer pads, or mica, or whatever they call it in English. We call it glimmer. It's a mineral. It's very flat, actually. It's very good. But I usually use silicone pads. I think they are better. They are longer lasting, probably. I don't like these. Yeah. But it's not wrong. If they are not cracked or anything, you can still use them. Also, this transistor, as you can see, it has some sheen to it, some colorful sheen. That's one layer of the mica. Mica cleaves at a crystal like very thin sheets, and they are very flat actually, and that makes them great for thermal pads. Back in the days, at least. But yeah, the thermal paste wasn't that great. You know what? I'm just gonna replace all of the transistors at this point. It makes no sense to desolder them, replace the thermal paste, and hope for the best. I just plug in some new ones with the same type, so the circuit works the same, should sound the same, but it will last probably longer. I'm not sure, but it will last for another 10 to 20 to 30 years. Or even I mean, this thing is 40 years old, right? 40 years. So as a last check, let me quickly check the thermal fuse. It should be short, right? It opens up when it gets too hot. That's good. I'm just gonna order some parts and we'll be back quite soon. For you at least. For me it takes like a week. So I decided to replace all of the transistors, replace the relays, replace the output terminals, because the other ones that you can't use with banana plugs, they have a hole but no contacts inside. And well, I just overhaul it completely and give it a power con socket on over there to have a detachable cable even. So let's go on with desoldering the transistors. Just waiting for my desoldering station to heat up. Oh boy, what have they done? At least they use good relays. Omron. But I'm gonna replace them. It's also a good idea to check that glue on the coils, because it can become conductive. So let's check with the multimeter to see if it became conductive, and yeah, I'm getting a reading. It's jumping all over, but that shouldn't be happening. The easy fix for that is just scrape away where it touches the jumper wires. It's very brittle. You can remove it completely, but that's not necessary. Just make sure it doesn't touch anything. So it doesn't cause further problems in the future. It's been several days later, and look what just arrived. Lots of goodies. Like new relays. These are capable up to 75 volts DC. They are 24 volt relays and have a connecting current capability of 40 amps, which is needed for this type of amp. And What else we have? Lots of capacitors. I usually order more than I need, so I have some spare in case I need some someday. And new resistors, new transistors. I went with different ones than the ones that are inside. They have the same gain, the same characteristics, but they are rated up to 230 volts instead of 200 it was. Because some of the original parts you can't get anymore. And the counterpart of it, well, yeah, I just went with the better ones. And they have the same current capability, the same power handling capability, they just have 30 volts more. They should exactly sound the same. And the best thing about all this rebuild is I'm changing out the power cord to a removable one, and look at this. That's a Nutric PowerCon True One. They look like so. And just listen to this. Isn't that nice? Yeah, I'm gonna use this obviously, and it has even a ratchet in the back, so you can't accidentally open it. If you want to open it later, you have to push in this little pin. Now I locked it obviously, and yeah, I will replace the original power cord with this removable plug, and may even use the original power cord for this plug here. Ideally I will use some rubber cable, some high quality stuff, but you know, cable don't make a difference. Only that you can remove the cable makes a difference, because when you store it somewhere, you know. Also, I'm missing new terminals for the back. They are still in the post. They may take they may take a few days still, and yeah, I get a second amp in the post in a few days, which I will also might make identical to this one. So a friend who wants them has two identical ones for bridged mono. If he has a pair of good Infinity speakers, and just looking for a nice preamp for these, probably going with a 1155 or 1240, so you stay at the same NAD series and not go to like the monitor series, which is horrible. And yeah, it's gonna be nice. So let's go on. I'm first gonna replace the relays. They are probably not gonna fit, or maybe. Wait a minute. Did I just found the right ones? That's rare. What the hell? Give me a second. Do you see that hole pattern? Now check the relay. It fits perfectly. I still have to get sure that all the pins make sense, because this is a single pole double throw switch, and if they all line up, I think I just found the perfect relays for this amp. The original ones are horrible. They are not hermetically sealed. They have a top you can open to clean them, but that makes no sense, because if you have a hermetically sealed relay, they don't oxidize. And this one is really, this is hermetically sealed. It should last basically forever, until it breaks, obviously. No. And yeah, if you want to replace relays on your own, these are the ones. I found them on Reichel, Germany, for like €1.50 each. That's nothing. Some guys on eBay even sell some relays on special boards to fit the pin out and such, and want like $25 for one or two. That's just a ripoff. And let me see if they fit before I do that. I just measure with the multimeter to see how those pins make any sense. Like these are connected together probably. Yeah, they're connected together. I just set it to continuity. They're connected together. That's normally closed and it's probably normally open. Yep. Oh, that's not normally closed. And that's obviously the coil. Yeah. And let me switch to resistance mode. That's the coil. As you can see, 370 ohms. That's good. About these two, I hope they are not connected together on the PCB. I think that's normally closed, normally open. Let me just plug one in quickly and see on the back. Hopefully they fit. They sure look like them. They sure look like they fit. Interesting. They have the same hole pattern, but don't seem to fit. That's weird. You know what? I'm just applying some paint to the pins so I can see where they're touching on the board. Yeah, just quickly apply some paint, or in this case thermal paste. It's a good paint. Just a dab on each pin, just like so. And now when I press it onto the board, I can see where the pins are touching. If I can even get there, like so. Yeah, I'm just way off. The pins are not quite where they should be. So I'm just gonna use a Dremel and just make them slotted to the bottom. And that's a Dremel. Let's see. I got power. Great. Milling bit. Like this one. And see if I can even get in there. It doesn't matter if I chew up the traces on the backside, just run a jumper wire. That's even good because it has lower resistance. And yeah, or just flood it with solder. It's fine. There we go. Looks good. So let's check if it fits. Let me see if I can align the pins. Not quite there yet. That's it. Oh, that's a tight one. That's a tight one. I'll probably mill them out on the back further. Let's turn it around. So this is where the pins went through. It looks good. I should have milled the holes a little bit more apart, not down. Let me check for continuity. Not that normally connected and normally open pins on the relay are connected to connected the wrong way. That would be bad, obviously. So let's check from the positive terminal to the input thingy. Where is the input? Should be this one. It's this one to this one, exactly. That's a normally closed and that's a normally open pin. So it fits. Not perfectly, but the pinout is right. That's great. Just have to scrape away a little bit of the solder mask here and solder a big chunk of blob of solder there. And I just repeat the procedure for the upper relay, but this time from the back, so I can see where I have to remove material. Again, this time mirrored. That looks good. We put in the second relay. It should just snap in very easily. If I find the right holes. Also a little bit tight, but that's good. It seems to fit. Great. Let's turn it back over. And let's see. Yeah. It looks perfect. This one pin isn't too far in yet. It's probably because there's still a little bit of solder, but that's fine. Let me check for continuity, so I don't have continuity unless it's turned on. Normally open is open, normally closed is closed. That's perfect. So let's just solder them in. That's it. So can solder this pin properly. Just like so. And also let me turn on the soldering station for the capacitor replacement. Solder. Good fluidine. It's not labeled fluidine, but you see it at the... yeah, there is it. Good 6040 leaded solder, the good one. The only good one, which you can't really get anymore unless you look on eBay for your old stock. I got myself a little bit of stock, so I never have to wonder where I get my solder from, if it's good, because this stuff is just good. Good enough for me, at least. Probably not if you work with BGA and such, but it's not its intended use case. So let me solder these pins. Get them good amount of solder there. Make a good connection. Remember, there's a lot of current flowing when you crank it up. This amp made like, what was it? Bridged mono or PPDL or whatever it's called. Yeah, bridged. 1200, 1400 watts into 4 ohms or something. Insane. Just like so. Perfect. So that's needed. Repaired it. They look just as if they belong there. So let's connect up this bit. Well, no, wait. I just leave it open because I need to take out this board later anyways. I also plan to replace the op amps with one that has lower noise. Let's see if that even works. Sometimes you can't just easily swap op amps. It may even start oscillating, but I'm sure it works. I already replaced in one amplifier the op amps with OPA 1612, which are the best ones you can get in terms of noise and distortion, and it worked just fine. I just had to solder a dip 8 socket on the back and cross the pins so the pinout matches, and it works just fine. The original ones in there are not bad. They have a noise figure in the microvolts range, and the ones I tend to use are a little bit better. They are down in the nanovolts range, not that it makes any difference. This amplifier boards, they have so much gain, they have more noise on themselves, but still this amplifier is quite good actually, from some measurements I've seen on the web, which I'm not sure if they are made with the original one or modified one, are down in the minus 130 dBs in noise. Let's replace the caps on this power board. It's the first thing to replace if you have a stuck protect LED. If none of the amps actually have failed, like in this case. But if the amps are fine, if you don't measure any DC offset on these pins over there, or on the emitter resistors, that is like 50 volts or something, then probably one of the caps has just dried out and it's stuck in the protection mode. So let me just swap them out. First, two big ones. They are 50 volts, 330 microfarads. Let me get them out. I already heated up the soldering pump. Well, let's go on. These are these points here, and then out underneath the cable. Just component just falls out. Best decision ever to replace the compressor on this cheap ass desoldering pump. Right, before I take them out, I'll look on the board to see if the negative is actually marked, because some boards don't do this. Some boards, some designers are clever and just put the negative in one direction, like to the right and back. And sometimes they don't, like you have the capacitors facing this way and these ones facing this way. You can mix them up, but if you're lucky, I mean most of the time it's this, like this, you have a white dot marking on the PCB that guides you the way. So just if you have a capacitor, just stick the longer lead opposite of the right marking. That's the positive lead. If you mix them up, you get a nasty surprise. So let's replace them. These are actually Rubicon. Not too bad. Focus, you fuck. Just won't do it. Piece of shit. These are 85 degrees rated, probably 1000 hours. Not great. I mean, after what it is, it's 85, so almost 40 years. Yeah, they never last forever. But I'm always using 105 degrees rated capacitors. They are not that much more expensive. We're talking here a few cents, like from 17 to 20 cents. That's, and they will last much longer. So let me just quickly find the right ones. Where are they? 330. Yeah, that's first pack I grab. Nice. And as I said, I always order more than I need. 3, I just need 2, in case I fuck up, or in case I just put them in my storage bin and put them in a list. And when I need a cap and I don't want to order stuff, I just look in the list and see, yeah, I have 2 of them in stock. And yeah, just gonna replace them anyways. I just drop them in like so. And if you look, I ordered just the best ones. It's no shit comes into my devices. These are Matsushita 105 degrees rated NHG. These are top of the line. Another capacitors that are top of the line are Panasonic. and yeah, Nichicon, obviously. These are my top picks. Elna maybe, but they're hard to get over here. You may even need to order them at some suppliers, and they're way too expensive. So, and it makes no difference. I mean, it's power filtering. So I just plug them in like so, and push from the back side a little, so they sit flush against the board, and just fix them with a dab of solder. So push from the back side so they don't flap around in the breeze. Also on this one, just a little bit so it's not moving, and then I just solder the other pin like so. Let me solder this one without touching the wire. Let it cool down a little so it doesn't move, and then just give the other pin a little bit. That's it. That's looking great. For trimming, I use these flush cutters. They're quite good, made by Viha. Not that expensive. Just cut them flush so they don't poke into these wires. Just like so. Perfect. Well, didn't do a very good job at this. Let me reiterate. Just like so. There we go. That's flush. Now I'll repeat that procedure for all capacitors. I will zoom out and probably speed up the video at this point, because it's literally just the same thing 100 times. Well, let's go. And I messed up. I'm missing one capacitor, 1 microfarad, 100 volts. I probably have it in my drawer for the capacitors. Let me quickly check it. That's my big box of capacitors. I probably have it somewhere, just not sure where. Let me just quickly find it. There we go. That was quick. 1 microfarad, 100 volts, one piece. That's why I said I just order one more than I need, usually. And that's exactly the case. And I probably should write that down, so next time I'm ordering them, because for the next one I will change it obviously too, and so I don't forget it. That's even one from Kemet, also quite good. Let's put it back in. So that tiny board is done. As I said, I don't want to replace the big ones, they are still fine. I never had an amplifier with failed big ones. You can replace them, but I bet you won't find them anywhere. These are 120 volts, 10,000 microfarads, and these are 80 volts, 10,000. They you might find, but these not. I looked everywhere. You find 100 volt types, but this amp is also already running at 100 volts on each rail. That's way too close. You want a little bit of headroom. So let's keep on going. I'm replacing the rest of the capacitors on both sides. Yeah, I'm some capacitors. 1025. I should have them. I should have 10 of them. Let me check again. I'm missing those capacitors. I forgot my order. What? Yeah, I'm missing components. Damn. Panasonic FC. 10 microfarads, 25 volts. Yeah. Another good reason to keep this box full of stuff. So I don't want to order them and wait another few days. Now that's weekend in between. So I just take the ones I have in case I have the right ones somewhere. It was 10 microfarads at 25 volts, or just 10 microfarads. I just can use anything from 25 upwards. Let me see. I don't want to use these. Oh. No. What are these? 1 microfarad. Oh, wait. They are 10 micro, 25. Why are they not writing it on this piece of paper? It is. These are the right ones. The red capacitors on the input terminal are actually low leakage capacitors. But yeah, that was from the 80s. Nowadays, if you get a low ESR capacitor, it has much lower leakage than the old ones. So just go with these. Don't bother. There are some Panasonic caps that are specifically designed for low leakage, but really, don't bother. So the right channel is done. Just nipping off those legs. And then I just have to do the left channel recapping. And after that I can do the transistors. There we go. All looks fine. Didn't miss any solder spots. So let's just let me quickly do the other side off camera, and we'll be back in a second. So there we go. I replaced all caps on both amplifier boards. I still have to replace the caps on the input board and the chips, obviously. But first I'm gonna fit the new potentiometers. Let me see where they are. 103, that's 10K, so let's do that first. It's over here somewhere. I have to check again. Yeah, I can't quite figure it out. Can I? Yeah, it's right over here. These 3 solder spots. Let me just quickly take it out. The old ones are not sealed and they may drift over time, and a drifting pot is never good, especially not if you set the idle current with it. A failed pot especially can destroy an amp this way. So just replace them with sealed ones, with good ones, new ones, just like so. That's a 103, that's on SVR 201, 103 linear. So let's just get a 103 pot like here. I hope the pin out, or the pin pitch fits. If not, I have to bend some legs. Not ideal, but the only choice. And these ones are, well, they are not hermetically sealed, but they're not totally open. Imagine if you have an open potentiometer and a drop of water comes down, like there are some spots where liquid has come inside, like you have to place, if you put your amp in front of an open window and it starts raining. And yeah, that's not great. So a pot that has a little bit protection at least, and it fits perfectly. It looks just like it belongs there. And I just grabbed a random one off the list that has the right value. It's perfect. So let me just quickly desolder the other pot as well. It is over, where is it? It's right over here. Oh, you can see it, it's right over there behind this coil. It's for, I'm not sure which one is which. One of them is for the offset adjustment, and I just put a big dab of thermal compound over there. It's awful stuff. One is for the offset adjustment and one is for the idle current, and obviously none of them should fail because then you have quite a bad day. I think that's the idle current one. Oh, it's not in focus. It's oh, let's pull it out, just like so. Great. That's a 1K one. It's the SVR 301. On the other side it's SVR 302. Quite easy to remember. So let's get the 1K pot. Same type, same brand, just so they look the same. You can use any 1K pot. They don't have to withstand a lot of power. They're really just for adjustment of a very low power signal. Ideally, it shouldn't drift over time or with temperature. They all drift a little. But yeah, a standard pot will do. I mean, the original ones are 40 years old. Literally just some carbon tracks on a phenolic board with a metallic wiper. That's literally all. There's nothing special. No conductive plastic, high-end bullshit ones. They just work. So let's just replace the ones on the other side as well. It is this one. And the other one is above. You can easily find them by looking at the bigger solder spots, circles, that are arranged in a triangle. So let's just flip it over and pull it out. I'm using Ateria clamps I found on a yard sale for cheap. You can get them online for like 11 bucks. They are quite good. They have very good grip and you can even lock them for use as clamps. So that's a 1K again. Let me just get the 1K right way around. Just like so. The other one is this one, SV202, the 10K one. Again, I'm using those pliers because I got some fat fingers that don't fit in here. Perfect. I'll just solder them in. Yeah, they're already soldered, right. The next step will be to fit those resistors that have burned. I already replaced 2 resistors I had on hand, and the other 2, let me quickly check, it's down on the other board below. Let me just quickly put it up here and let me zoom in. It's probably somewhere over there, right here. R332, R332. On the other side it's R331 and it's fitted. I think this was a 470 ohm. Let me quickly check on the datasheet. Just like so, I just look up the number. It was 332 and 376. So 332 is quarter of a watt, 470 ohms, and 336 is a, was it 336? 376. It was a quarter of a watt, 470 ohm. And I got the right ones here. These are 330 ohms, these are 470 ohms. Let's get a tablet out of the way. And if you look at the resistors on this board, what do you see? Well, it's hard to see on camera actually. I mean, it's a little bit discolored on this side, don't bother. If you look on these resistors, carbon composite resistors or metal film or whatever they are, they sit flush on the board. That's because they are not fusible. If they really burn up, well, they just catch flames and destroy the board. If you look at these are usually sitting on some high power areas. These are fusible resistors, metal oxide I think it was, and they are made from some sort of ceramic, and when they burn up they just start glowing and then go open like a fuse. They don't catch fire, which will be bad if you remember they stated this amp was in with a lot of dust. Not only that, if you look on the board, they are not sitting flush. That's because if they burn up, well, they char up the board, and a charred up paper, resin, phenolic board becomes a resistor itself. That's not good and can cause further problems. So I just put the new ones in, one here, and I just give them like a centimeter of space to the board. If I can fit it over there, perfect. And just solder them in. And if they ever go bad, they don't burn a hole in the board. That's it, just snip those legs. I don't bother removing the legs from the case, because before I turn it on, I will check every spot so I don't bridge anything, and I shake it a lot, so if any loose solder blobs or anything is still in here, they will fall out. And I just noticed I've bent the chassis a little bit. Great, so all the components on this board are replaced. I hope those transistors I measured are fine, actually. I mean, they're measured fine. The base emitter and collector junction are measuring like a diode. This doesn't mean they're working, but the chance is high that they are working. I don't think they're not working. And let me fit the new transistors. I already marked the spots where the black ones go, so I don't have to look up. Oh, before I forget it, obviously, the new resistors. Right, the new resistors. I mean, I could leave the old ones in here. You know what, I think I leave the old ones in here and just replace the broken one with the new ones. These are 0.22 ohms, 220 milliohms, 7 watt jobbies. The ones in here are 2 times 220 milliohms, 10 watt, so 2 times 5 watt. So they should just work fine. And I just bend over the legs like so. Over here. Back down, a little bit short maybe, just like so, and put it in the hole like this. It should just fit in. There's the spot for the new resistor. I just plug it in like so. It fits perfectly, and the other one as well. The original ones are also just 2 resistors that meet in the middle. Let me see, maybe it's too short. Should just fit in, or maybe I have to drill out the hole. I'm not sure. Yeah, I think I have to enlarge the hole a little bit. Not by much, maybe 0.5 millimeter. So let's just drill in here. Yeah. works fine. I'll put the new ones in here, just like so. That's really nice. Oh. And these are the legs of the new resistors. The middle ones actually stick out just enough, so I don't even have to snip them. It's just perfect. I don't quite like how close the resistors are sitting to the board, but when they burn up, they usually do it within milliseconds, so they don't even get hot. So they don't char up the board. If you look at earlier in the video on the original one that has failed, it didn't look like it had failed from the outside. They don't get hot before the protection circuit kicks in. So it's a little harder to solder, it seems, or is it just the lighting? I'm not sure. This leg has a little bit of glue on it. Just scrape it, just like so. Perfect. And snip it off. Now I'm gonna fit the resistor. Now I'm gonna fit the transistors. First off, the middle one, and if you look on the back, they have a plastic back and these have a metal back, and when I put them on here, I will short them to the heatsink, which is ground. It's not great, so I just add an insulator pad to them. I don't need a plastic washer because the front side is isolated, so that's just when you get an isolator pad. Like these are the plastic washers I don't need, and these are the silicone pads, which I think are superior to the original mica ones, which, yeah, they don't look too good anymore. I just trimmed them down for the smaller transistor size so they don't stick out too much, or maybe I can even combine them together with the temperature sensor. Let me check. No, I have to trim it. Look that the hole will line up. Press a little bit so it sticks. And add a little thermal compound over here. Now the transistor. Let me quickly arrange this like so. Transistor on the left. There we go. Just screw it in. And this metal bracket should go over under? I'm not sure. I just put it under so it doesn't sag. There we go. Just be sure for the insulator pad to fully cover the transistor. I may even put it a little bit under the temperature sensor. Yeah, that's good. Crank it down. Add a second screw for the metal bracket, so it's also securely held down. And now the transistors. Now the black ones, the original black ones. Where these ones, these are SC3281, and the green ones here, and here are SA1302, and I think one of them I couldn't get anymore, and the SC3281s, I think I can replace them with the SC5200s. Just let me quickly check. Yeah, the original SC3281s are 200 volts, with an emitter base voltage of maximum of 5 volts, 15 amps, 150 watts, 55 to 160 gain, and the new ones are 230 volts, 5 volts, 15 amps. Also, it has the exact same gain, it just has a little higher transition frequency from 10 to, for the new ones, to 30 megahertz. Affect the circuit, so let's just put them in 3 times for each side, and I add a little bit of thermal paste on here, over here, here and here. Then I'm using a small screwdriver to put it in the hole and align the pad. It should stick to the thermal paste, just like so. Getting sure that they are clean, no dust or debris on there, so they make a good connection. I'm not even sure if the thermal compound is necessary. I just add some. It wouldn't hurt. And the stuff you get today is much better than the old stuff. I hope it will last another 40 years without drying up too much. So let me add the big transistors now. First one over there. And I see the thermal compound squeezing out on the side. That means I applied in just the right amount. Some people think the original transistors are superior. Some think Sanken transistors are superior. Some other think, well, I don't know, some magic brand from Japan is the real deal and whatnot. Well, I think you can't even hear the difference between them, and I just go with the latest because technology advancements have been made over the years, so why go with the old one? And well, if you can't get the old ones anymore anyway, so what's your options? So let me just quickly get them here. Using some tweezers, I just cut them flush. Let's add the other transistors. These are the other ones, SA1943, and the original ones were, just had one, they were the green ones, SA1302. Again, these are the counterparts to the ones I just fitted. They're also from ISC Semi, and these are the PNP, I think, counterparts to them, so they should play nicely together. Again, I add a little bit of thermal compound. I can't remember what's going there. I think nothing. Just like so. just bolt them down. And one screw almost went, and on one screw almost went into the 9th dimension. That wouldn't be great because I don't have them. I only have black ones and I don't want to mix them up, even if you can see them. Just like so, that looks great. 2 more. Thermal compound is squeezing out nicely, making good thermal connection to the heatsink. Good thermal dissipation means good lifetime. Again, I just snip the legs a little so they don't touch parts they are not supposed to. And that's it. I press them down on the board a little so they are close enough to the pad so I can solder them. Great. And now just add a lot of solder. I just get a big reel, big stuff. One and a half millimeters, and I crank up the temperature a little bit to 370 so it heats up quicker, and just give it out just like so. It looks really nice. Fresh solder fresh legs on components take solder much better than if they were 40 years old and already oxidized beyond everything. Making a good connection. Because I'm doing this upright, I've got a little bit of problem right now. Just to clean up a little, there is too much solder which can drip down. Just add a little here, a little there, Make sure nothing will bridge. It looks good. Just like so. Push that one in. That looks really nice. All connections are properly made. And this side is now finished. Let's continue with the other side. Great, it's looking good so far. Let me just quickly check for a short to ground, so I know I didn't mess up. So these are the negative pins, so okay, no. No shorts. Again, these are the negative pins, so I just clip onto them directly. No shorts. That's good. What I've expected. Alright, now let's get this board out. Just a few screws. Okay, someone already replaced the up amps with OPA 2134. That's nice. They're not bad. But what I see, I don't really like this conductive glue over there, which, well, as brittle as it is, it really became conductive, it seems. Just let me quickly check this on the multimeter, so I can untangle the wires. You can see the reading, and then when I touch the glue, see, that shouldn't happen. So I just quickly get rid of that glue. It's good that they socketed even the op amps, that's nice. The guy that worked on this amp before. He obviously knew what he's doing, except for the relay story. Maybe he couldn't find the right ones. And I close my eyes when I scrape on this glue. It's quite nasty. Safety squint engaged. Oh, shooting like little bullets. But it breaks away quite easily. But there's a lot of it. I don't want to cut the cable tie, so just get rid of it like so. And that's good enough, I think. Let's the last piece over there. Just like so. That's good enough. Nothing is bridging anymore. Same on this side. There's a resistor that got eaten by the glue, it seems. And yeah, luckily not much has gone wrong. So let's just replace those capacitors as well. This one is a Rubicon, 25 volt, 10 microfarads. This one as well, and these two are 100 microfarads, 10 volt, and 10 volt, also 100 microfarads. And these are the low leakage ones, which we don't need to replace with low leakage ones, as I said. So let's just get them out. And also this board looks a bit different, and if you notice on this leg, maybe if you can see it, the line on this side is a little bit thicker. That means this side is negative, and they did a good practice on this board by aligning negative in all the same direction, like left and down. So quite easy to remember. Let me just heat up the desoldering station again. While it's heating up, I just can clean the switches using a cleaning spray that also has a little bit of oil in it, and actuate it a few times. That should do it. Same for the switch over here. Same here. There we go. Let it switch to stereo. Now I can remove the capacitors. First this one, sitting over here. And the other one. So, take them out. And these were the 25 volt 10 microfarad ones. Let me just quickly get some new ones. Yeah, right, these were the ones that the seller forgot. So I just picked them from my bin of capacitors somewhere. And if I have them, I think the ones I used were the last ones. Well, these are just the input capacitors. I just can use bigger ones. Shouldn't do much. Tend to stick to the original values most of the time, if I can. Nope, nope, nope. Nope. 100. Just need 2 of them. 47. 2216. No, these were 2210. No, 25 volts 10. 25 volts 7. Could use 2 of them instead. Nope. These are some bigger packs. Nope. 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 These are bipolar. Won't work. Let me check these ones. These are not name brand ones. These are cheap Chinese ones. But they are still fine. Nope. What about these? Nope. U 25 volts. These are the right ones, and these are GA. There are a few different types from Panasonic. FR is like low ESR. GA is like low leakage or something, and SA is, I think, bipolar or something. Can't quite remember. Let's just put them in. The op-amps the previous guy used are probably quite good. I look up the data sheet in a second. But I want to replace them because I don't have them here. And if I want to make 2 amps identical, I also want to use 2 sets of identical op-amps, obviously. And my soldering iron went into sleep mode. Smaller reel. Now the last ones, these were the 10 volt 100 microfarad types. Just get them out. Which one? I think this one was it. Yeah. Volt 100 microfarad 2 times. Again, in my parts bin I probably have them. (116 volt). You can always go higher in voltage. Not too much because the ESR goes up, but from 10 volts to 16 volts is, I think, no big deal. But yeah, I have the right ones. 100 microfarad, 10 volt. Just put them back the other one. These are the right ones. 2 of them. Just lock them in, bend them over like so. Again, looking where the where the thick line is, that's a negative. And I think I have to bend it over like this. Just solder it in. If you put a cap in backwards, it will act as a resistor. And if you have power behind it, a voltage rail that has a little bit of power, it will heat up and it will create pressure inside and blow up. If you have an input capacitor or any signal capacitor, that when it acts as a resistor, it's not good. It can just pass current if it's supposed to block current. And yeah, I once had that issue with one. A friend who also restores parts put one in backwards, and it took quite a while to find it. Here's another dab of that awful glue, which I want to remove. It comes off quite easily. That's good. That's good enough. And over there is more glue. Even if it's in the 100 megohms range, it's still not desirable to have it. There we go. This looks really nice. There's a lot more glue I just found. Let's just get rid of that as well. Just scrape on it like crazy. There we go. Nice. Now I just need to replace the op amps with the ones I wanted to use. These are probably fine, but as I said, I don't want to use them, but I want to keep them. They're probably not cheap ones. Right, I want to look up the datasheet. These are, as I said, OPA 2134. Let me just quickly check the datasheet. 2134, and they cost on Reichelt €5 each. The ones I put in cost like €2 each, so they're probably better. They're probably much better, but you don't hear a difference. And as I said, I want 2 identical ones, so let's just open the datasheet. And 8 nanovolts, squared hertz, so extremely low noise. These are ultra low distortion with 4 zeros and 8 after the decimal point, so they're quite good actually. They're comparable with the OPA 1612, which has 1.1 nanovolts of noise. And the ones I'm using right now I think have 5 or something. So it's a little bit better than these, maybe. These are the LM4562, also from Texas Instruments, genuine parts, and I just plug them in, looking for the white dot. I hope they fit these sockets perfectly. And the next one, looking for the white dot. Nice. Great, great. Now let's put it back together. And see if I remember which screws I used. Not that it matters. these ones were fine threads for the switches. M3 probably. And I'm slipping the screwdriver, I need a different one. I probably should add another screw on the bottom switch. Normally there's a cover over there to prevent accidents, and I messed up. This screw is too long. Yeah, I don't have these small screws in stock, so I can't add 2 of them. This should work just fine. Great. Now probably half of my footage is messed up by now. Great. Now I just plug in all the wires, and then we can turn it on for the first time. See what it does, if it goes up in smoke instantly. If you hear the relays click, everything is fine. If not, we maybe have to adjust the DC offset a little. And if it still don't click after that, we have a problem. Just let me plug in both amplifier boards, like so. Just tidy up the wiring a little bit. It all looks really. So let's plug it into the isolation transformer and slowly bring it up, watching the current draw. Yeah, it looks good. The relays clicked. Did you hear that? Perfect. Now, the current draw is almost nothing. That's good. That means the idle current isn't too far out. Let me quickly add some probes on the output so I can adjust the DC offset. The DC offset, ideally, should be adjusted to 0. Right now we have about 24 millivolts. That's not too bad actually, and I just wanted to be a little less. I hope. No, that's the wrong pot. I think the other one is it. Yeah, I should go to the right channel, I think. Would make more sense. You see, it's very touchy. Perfect. Almost 0. That's in the microvolts range. Looking great. Now let me connect to the other channel, which I just messed up by looking at it. Like so. And I think I don't have a good connection. You know I have. 28 millivolts. Let me adjust that to something that makes more sense. Just like so. Everything below 1 millivolt is perfect. And let me turn it off again. And back on. It's overload, obviously, and it settles again to the value of I set. Let's check the other channel again. And it's perfect as well. Great. Now to the idle bias adjustment. There is a header on the inside where you can hook on a header basically to easily adjust it. I don't have this particular connector, so I just use some clips. It's a TP201 and TP202, and I have to adjust it to read 7.5 millivolts. That's at 0.22 ohms. I think it's around 20 to 25 milliamps on the transistors. It's the perfect amount. So let me turn it off so the caps discharge a little bit, because when I slip on these terminals I've already blown one up, an amplifier, and just being a little bit more careful this time. For hooking it up, I'm using such clips. These are the best to connect to these connections. Just let me plug them in and go a little bit down so you can see better. You see, these are the terminals I have to connect to. I don't know if I need to connect to both or just one and the other one to ground. I think both is good. Just like so. Let's turn it on. And I'm reading 6 microvolts. That's a little low. There we go. Now I'm shooting for 7 millivolts. It doesn't matter if negative or positive, because I don't know which way around I put the probes. And I overshot it a little bit back. I'm fine when I'm within 0.5 millivolts, but I mean it drifts over time. I set it now to a value that makes sense, let it heat up for a while, and set it again because it will drift again. I will listen to some music, and after 10 minutes I will adjust the value again. Now it's set to 8 millivolts and it's rising. Now let me turn it off. Remove the probe carefully so I don't short anything. And let me repeat that for the lower amplifier as well. This one I should read positive because they're mirrored, which I do. And that really made me jump. There we go, it's rising. Not quite sure what's going on, because I can't reach the 7.5 and I'm already bottoming out the pot. Now it's rising above 7.5, that's good. So I can set it to 7.5. And it's rising again because it's heating up the heatsink. That's okay. I will check that later again. Just remove the probes. Now for the final test, let's put in some music. Just removing the multimeter probes over there. Plug in an RCA cable into the lab input, right and left. Let me just hook it to my iPod, find a good track to listen to, which my YouTube video won't get blocked at. Just like so. And get an amplifier and some jumper wires. It's not a great speaker, but it should do the job. And right, yeah, that's why I want to replace these damn banana posts, because they are not banana posts. You got a hole, but you can't plug in a fucking banana thing. Yeah, that's one reason. I'm just using these multimeter crocodile clips. These should just work fine. These are not too bad. Just have to screw it all out almost all the way so I can hook onto it. Like so. One channel at a time. Perfect. Now find a track that works. Lower the volume quite a bit. And now let's listen if there are any pops or crackles. The music is playing. Quickly check the other channel as well. Perfect. Alright, this amplifier is almost done. I just want to replace the power connector as a last step, and obviously the speaker terminals which haven't arrived yet in the mail. But I won't make them on video. It's quite easy, just desolder these, screw the new ones in and hook them up. Nothing special. Now let's turn off the amplifier, unplug it, and turn off the iPod. Alright, and there you go. So my plan is to remove the cable, drill in there and add the new connector. Let's see if I can put this amp a little bit further, like so. Just removing this plug by biting onto it like this or something. Not quite sure how they work. I think it was, yeah, right. Now I can pull it out. A little bit more. Like so. Perfect. Exactly what I want. So, just unhook this one. And be sure to have it unplugged for the next step, because yeah, that would have hurt. So that's good. The old plug doesn't have grounding, On amplifiers that's not desirable because you can create ground loops. So I want add grounding, but I will be very careful doing the next steps, so I don't have 220 on the outer casing. And I hope I don't mess up the wires like this. Perfect. And I didn't mess up the wires like a pro. Just repeat that for the other cable as well. I have a little bit more room for error on this one. Like so. I a little bit hurt the insulation but didn't cut through. Just add a little bit like so. Great. Same for these ones. I'll put a little bit more. Like so. So a little bit more. Because I need to crimp some spade terminals on them for the new connector. Before I do that, I have to drill out the hole, enlarge it a little bit. The new hole has to be 23 millimeters. A little over 23. Let me see if my step drill actually can go this big. No, it's just 22, so I have to go to the basement and get the bigger step drill. Well, we'll be right back. So there's the other step drill. I can go to 24 millimeters with this one, and I think that's too close to the bottom. I don't think that will work. Not great. Not great at all. Damn. Just let me see. No, that will not work. I maybe have to drill it a little bit further up so there's enough room for the connector, and just plug that hole with something. Oh yeah, let's do that. It's gonna be messy. It's gonna be messy. Let's see where I got enough space. Here. Right in the text. And I'm almost hitting the heatsink, and I still have to go a few steps. I don't want to remove that amplifier board, actually. Let me just quickly... No. Just bend back those fins a little. Don't want to take everything out just for that step drill. And one more. That wasn't too bad, actually. A little bit mangled up the heatsink with a small hole. No one will see. Keep going on, nothing to see. Just shavings out of there. That's good. And get the plug in so it doesn't touch the heatsink too much. I think I just removed one of the fins for this. One fin less shouldn't hurt the performance at all. Just work hard on it a little, and that's great. That should work. Now I put in the new connector and mark those holes, drill them out and put it in. Just like so. I've marked the spots I have to drill. Over here and over here. Let me quickly check it third time. Yep. I'm just using a 2mm drill, so those sheet screws got something to bite into. Nice. Now let's add those cable shoes and some heat shrinking. I like to bend them over there a little bit so they don't go flying everywhere. Give it a good punch with a crimping tool. Just like so. That makes a good connection. Same for this one. Just bend over those wires a little so they catch onto that. Again, crimping tool, like so, all the way to the front. There we go. Looking good. Now to heat shrinking, just over there. A little bit too long. just for a little bit of safety. Just like so. I'll mix it with a lighter. Perfect. Looking good. Now for this connector, just pulling the wires through here on the back. These connectors have written on the back which pins are which, and I only need live and neutral because we have no ground. So let's add this one, and then we triple check. Yep, this one. Making a good connection. Making a really good connection. And I probably should put this heatsink on the back a little bit further to the back, just so the wires don't touch it. I mean, there's 220 volts. These are live. When the heatsink gets really hot, I don't want them to melt or anything. That's good enough. There's about 2 millimeters of gap and insulation and everything. Let's get some screws. I don't have any that will fit. Maybe, let me see. There are button head, so not optimal, but these could fit. Yeah, they go into the hole. Get a little bit of force. I maybe should use a screwdriver that bites a little bit better, so that I don't destroy the screw before it's in. Oh, that's perfect. That's looking good. The last one. That's really nice. And did I put it in the wrong way? Yeah, I did. I'm an idiot. Because I'm an idiot. I have to rotate the... So we have the unlocking button on the top. No big deal. Just put this thing back in so it doesn't flap around the breeze. I hope it fits in there. It doesn't, so I just cut a little bit of wire which I can stick in there so it's sitting flush. Wire without conductors. Just put it in here, squeeze it together so the hole is plugged. I don't have any special plugs that can go in there. I gotta use what I have. Just press it together and put it into the hole. Just like so. Perfect. Now the cable part. The cable part. I think that's the easier part. Also, this cable doesn't have grounding. So it's really just connecting two wires. And I've damaged the wires, so let's cut it. I need the right tool for the right job, but I don't do this often, so this will do, just like so. Don't need to add any metal metal heads, and just unlock this connector again, like so. Really easy. Pull out the block, pull out this one. To lock it in, they even have hex head screws, so you know it's really high quality. And yeah, just a Torx screwdriver, because they will fit hex head screws just fine. If you find the right size, like this one. And yeah, just before I do that, obviously, first add the parts you always forget, like so. Then this one, then this one. No, wait, like so. This. Yeah, right. And order of assembly. I always forget to add these when I make XLR cables. So let's put this in neutral and this in live. Flush, it's sitting all the way in. And just tighten up the screw. Good and tight, not too tight to not break the cable. Just like so. That's really solid. And now I just plug it in, find the indexing mark, like so. Just slides in really easily, really smooth. And now the best part of this connector, listen. That's one really nice connector. So let's unplug it in, see how it fits. Like it's meant this way. I mean, it's so strong I could even lift the amp on the cable, which I won't do. Oh, listen to that. Oh, nice. Alright, great. So let's plug into my isolation transformer, into the amplifier. Be sure to turn it on and crank up the voltage and turn it on and see if the relays click. It's done. Turn it back off. Great. Now I just have to reassemble it and the job is finished for now. I mean, well, I can just leave it disassembled until I replace the connectors. Yeah, I think I just leave it disassembled for now. Just put it on a shelf until the connectors arrive, and then it's ready. So I couldn't finish the video without closing up the amp. It is working, but it's still missing its banana terminals. And they arrived today in the mail. These are the ones I'm gonna be using. So let's get the amp back on the bench. And I need a bigger bench, it seems. And there we go. Now get the old terminals out. And the new ones in. Hopefully they fit. I mean, they have the same pitch, but the holes are bigger. But it shouldn't matter since we have a plastic spacer. So let's get them out. To freshen it up a little with a little bit of new flux inside. I could use solder wick to get it off, but I'm not a fan of it. I'm not a fan of wasting solder wick, so I'm just using these vacuum desoldering tools. They work fine. This kind of job. I've added a little bit of silicone hosing on the front, so I can get closer to the PCB for a better vacuum seal, and this helps a lot. And as you can see, very clean. That should be it. Let me check the pins. They're all loose. Yep. They're all loose now. I think I can just pull it out. There's two plastic tabs on the bottom. And let me flip over the end. Oh, it's a little bit tricky to get in there. I'm just bending up those pins, but first I gotta remove this ribbon cable again. Maybe I even remove the PCB to have better access. And don't mix up the screws this time. Okay, it's a little bit tight in here, so let's just pull out those pins. And I think I even need to remove the PCB itself. Not what I have planned. Let's see if I can get it out without removing it. Plan B. The good thing about those NAD amplifiers is that they are basically fully modular. You can take off every sheet metal, every part, because nothing is welded or stamped. So if I just rotate it like so, you can see I have a bunch of screws. I can just take off the whole back panel. Let's take out those screws. The replacement should be quite easy. You know what? Fuck it. I'm lazy. Perfect. bottom ones are a little bit longer. It seemed, no, it just was this one screw. So one's been in here before. I should use a different bit. Let's see, does this fit better? Nope. Not sure what screws there are. This seems to work fine. Last screw. See, that's the NAD experience. Just as easy as that. You won't find that on other brands. That's the old terminal. And as you can maybe see inside, there are no metal contacts, so you can't use banana plugs in them. What a terrible oversight by the designers. I mean, I think that's an older model, a pretty early model actually, because I had some 2200 before that had actually a metal insert. Yeah, I'm gonna replace it anyway, so I mean it fits if I crank on it like an idiot. And I put it even in the wrong way around, so I'm just putting it in to see how it looks. I don't like that there's a big gap. I'm just trying something. I'm taking out the original binding posts. They have a flat spot on the thread, so they don't come out easily. Just forcing them out. Don't use this anymore. And let's see if I can put these one in here somehow. Maybe if I mill away this part and bore it out and somehow get it in there. Let's see. So I removed the metal inserts, nipped off the plastic part and sanded it down. It's not ideal because I burned through here by trying to drilling it. And I'm gonna just use it as a guide for the plastic parts. So let's get it back in. Since I can poke it through once it's in. So let's just add back the screws. So and poke through the new connectors. I screwed out the upper part a little so it doesn't squish. And they should fit. A little bit loose, but I think it's gonna pull itself in. At the other part on the back, and that should work. Looks good. And the nut. There's not much thread left on the back, so let's see if I can even put on the second nut or if I have to solder it. Now pulling the stud through. It's rotating, so I have to poke through a screwdriver. Like so. This way I can also get sure that the banana port is facing upwards. And it poked through. Nice, and just crank on it a little harder, like so. Maybe a little too hard. And the banana port is facing the right way. Just repeat that for the other side as well. Rotate it like so. And give it another twist or two until it feels solid. And just a little backing off, like so. Perfect. I hope I didn't squish the plastic too much. Let's see if I can plug in a banana plug. I mean, these are just for bare wires actually, so I can plug it, but it's quite hard. They are not meant for banana plugs anyways, so when I screw them down, I can just plug it in here, like so, the way it's meant. Let's repeat that for the other side as well. Unscrewing them a little. They fit much nicer this time. Not ideal. Let me quickly align those pins. This looking good. And these are a bit further in, so I don't think I can get a nut on there. I think I'm just gonna solder a cable on this. It should be much easier. And yeah, I cut myself, obviously. Let's hope the plastic doesn't melt. I should increase the temperature a little bit so there's maximum heat transfer going on. Getting the top part of the metal hot before the plastic gets hot, just like so. Just like this. Getting rid of the solder blobs. It's looking nice. So let's see how far I have to trim the wires. Seems like just on this edge, maybe a little bit further down. Just right around. Let's see here. That's good. Tinning the leads, but reducing the temperature again so it doesn't spatter that much. There we go. And just putting it back in. I think I need to drill out the holes just a little bit. So let's get the bottom panel back on. Now I just turn it on, let it run for a few minutes, and then I set the idle adjustment again, and then I'm done. Just two small speakers to get a little bit of load. Yeah, I probably should connect the RCA jack first. Second one. Both are working. It's great. So, it's up to temperature. Let me check the idle and the offset again. Over here. Turn it on. There we go. 2 millivolts going down. Hope you can see it on the video. That's going towards 0, almost perfect. Don't need to touch it. But it should settle around there. Let me check the other channel. Yeah, almost 0. That's in the microvolts range. That's perfect. Don't need to touch that. So let me attach it to the offset adjustment test points while it's turned off. I mean, the capacitors are still charged, so if I slip, already burned 1 amp one day, and it's still rising a little. It should be at 7.5. I mean, it's quite open. I have a fan blowing nearby, so when the heatsink cools down, the offset adjustment also goes down. And I think it starts settling at 7.5. I don't need to touch it again. That's nice. Let me check the other channel. Again, same test points. TP202 this time. Will still rise a little bit, as normal, when it heats up. I think that's good enough. Get off the probes. Now I just put it back on the lid, and I'm done. Not the best condition, but what do you expect? It's 40 years old. It's a workhorse, not a shelf queen. NAD never looked great, but they always worked. I'd rather have an amplifier that works very good, very well, has lots of power, sounds great, than one that just looks pretty. You're right, it's missing some screws. I think I have some. Let me check. There's still a few screws missing. Yeah, I don't have the right ones. These are M4 screws. I think they poke out too far. I may just use these. Some hex head screws, some small ones. Yeah. It's on the sides, you don't see it. Doesn't matter. There's another one that could fit with a broken washer. Oh, let me find the third one, like so. It's good. Good enough. Yeah, that works. A little bit skewed. It pulls itself in, great. Just like so. And now the back side. Just 2 screws. I think I'm gonna use these. Some hex head screws. A bit long, but the only black ones I have. Great. Now, to summarize. When I fix this 2200 PE, which it doesn't state on the back but on the front, and you can see that's a PE because it has the 2 positives on the inside and not positive negative like the non-PE version. I'll replace the power jack with a power control one, really nice one, and I replaced the binding posts. I repaired the amplifier boards, replaced all the transistors on the power stage because 2 of them were blown, 3 resistors, all capacitors, and new relays, and fixed the amp to 220 volts instead of having this weird ass selector. And yeah, It should last for another 40 years, I hope. And that's it. That was the restoration. I'm Gamerpenny, and thanks for watching.